Morning, dear students. Today in this section, we are going to learn about branchiostoma. In the former class, we have just learned about its general features, and in that section, I have told you that next video we will learn in detail about the branchiostoma. It is otherwise called Amphioxus. So let's start. Its popular name is lancelet because of its similarity with this lancet that we oftenly use to prick our finger to collect blood. So, because of this appearance, it got the name lancelet. Who discovered and described this Amphioxus or Branchiostoma is by a German taxonomist Pallas in 1778, and the name is given by Yarrell in 1836. What about the habit? It is a marine animal. It lives in marine environment, and especially in the shallow offshore sands, means it is seen towards the offshore sands in temperate oceans. So I'm going to show you one video to show the means it what pattern it moves, and regarding its body plan, and also how it's here you can see its movement, undulating movement, and this type of movement it show during the night time. And And inside the body, we can see this is the pharynx, perforated pharynx with numerous gill slits, and that space is atrium. It opens out by atriopore. It was all myomeres, muscle bands, then notochord, uh, tail region. So we are going to see next about the evolution of its notochord as moves to higher vertebrate forms. So this is the notochord. It forms later. It may develop to a vertebral column of higher organisms. Like in elephant, we can see that one here, here. That's the main supporting structure. Here also we can see this vertebral notochord evolved to a vertebral column that forms the main supporting structure for all these organisms. So that's what I'm just I intended to show you its movement and all those things. In what way? Okay. That's about that Amphioxus. And during the daytime, I already shown in that video that daytime it rests inside that sand by digging a burrow, keeping its body upright, exposing its anterior end outside. And during night time, it comes out from the sand that burrow, and then it actively swims in the water and collects its food by the undulating movement of its body. So that's about its habit. Then regarding the other features, its length is 5 to 7 centimeter long, and body, we can see that slender, laterally compressed and pointed at both ends. And that posterior end, this end is more tapering. It is more tapering. Body, it is translucent, transparent, somewhat transparent, and the color is faint flesh color. And that body we can divide mainly into how many regions? Two regions: anterior big trunk region and a short posterior tail. So these are the two divisions. A distinct head is absent, and that anterior end of the trunk, it projects in front and form a snout or rostrum because of the extension of the notochord. I already told you about that in the former video while discussing the general characteristics of cephalochords. Okay, anyway, leave that. Then how many openings it possesses in his body? Mainly three openings are present. Which are the three openings? Mouth is there. This is the mouth. This portion. This is the mouth. Mouth. Then atriopore. Atriopore is this one. Atriopore is there. And then anus. Anus towards the posterior end of the body. I will show you later. And oral hood, another structure. Oral hood is this much portion. This much portion. So what is oral hood? It is a tentaculate structure with tentacle bearing structure at the anterior end below the rostrum. So this is the rostrum that is formed because of the extension of notochord. So below that rostrum present this tentaculate structure. Its name is oral hood. And this oral hood, it is a part of the digestive system of cephalochordates. And it has a frill like a membranous structure. And how it formed? It formed because of the outward extension of the integument. Integument means skin of this organism. It is formed by the outward extension of the integument, and it opens outside by a wide oval aperture is called the mouth. And it is bordered by so many finger-like process. The name of that finger-like process is called oral cirri or buccal cirri. How many cirri are usually present? 10 to 11 pairs in pairs they present here. That much series finger like structures are present in the case of cephalochordates. And these series are slender, it is flexible, it is not rigid, and it is ciliated. And what's its purpose? It bears some sensory papillae. So sensory also is function. And buccal cavity. Next structure is buccal cavity. This is the buccal cavity. It is always called a vestibule. And in what way we can explain about this buccal cavity? It is the spacious cavity inside the oral hood. So that is vestibule, and it opens into mouth. This buccal cavity or vestibule, it opens into the mouth. And this buccal cavity is lined by what? It is lined by ectoderm. And as it is lined by ectoderm, this buccal cavity or vestibule is considered as the stomadium. Stomadium means what? Stomadium means it's a mouth of embryo. Embryonic means it is a mouth part present in the embryo during its developmental stage, and later it will become a part of the alimentary canal between mouth and stomach. So stomadium means it is a part of the, or it acts as the mouth in embryo. Later it will become a part of the alimentary canal between mouth and the stomach. So this buccal cavity or vestibule is lined by ectoderm. It is considered as a stomadium. Okay. Then another structure. What's the name of another structure? Wheel organ or Muller's organ is very important. It also has so many times as 1 mark question for your university examination. What about this structure? What do you mean by this Wheeler's organ or wheel organ or Muller's organ? This structure is present in this area. I will show you. This is the wheel organ or Muller's organ. A pair. So it has there are some grooved ridges, but also it possesses so many cilias. And one more picture is there. So in this picture we can see the cilias that present on the margin of that grooved ridges. A groove is there in the center of each finger-like process. Groove is there. So this is the appearance of the wheel organ of this Amphioxus. What are these organs? They are the foldings. They are the foldings of ectodermal lining of the vestibule. We just seen that what is its appearance. What is Muller's organ? They are foldings of the ectodermal lining of the vestibule. This is vestibule. Its ectoderm lining forms certain folding. And what about the number 6 to 8 pairs of foldings are present? And those foldings, as I shown in the former picture, they are ciliated and with a grooved ridge. And what about the function? Because of the coordinated movement of the cilia on that each fold of the wheel organ, it set up a whirling, rotating verb of water current for what? To bring all the microscopic organism into its mouth. So that is the purpose of that wheel organ or Muller's organ, this organ. They're foldings of that ectoderm lining of vestibule, and it is ciliated. We can see it is ciliated. By the beating of it creates water current, and by that way can collect microorganisms. Next, Hatch's groove. Yeah, Hatch's groove also is a groove that is seen as part of the wheel organ or Muller's organ, and that groove, it is the mid-dorsal tract. Wheel organ we have just seen. We know what is wheel organ. So in that wheel organ, the largest one and the middle one, and also a dorsal one. Largest one, the middle one, and the dorsal one among the wheel organ. Wheel organ we have seen that finger like folding because of the folding formed out of the ectoderm lining of vestibule. So among the foldings, the largest middle dorsal one, uh, that dorsal tract, it is called a Hatch's groove. I will show you in this picture. So this is the biggest largest mid dorsal tract. That groove, it possesses a groove. That groove is called Hatch's groove, and that groove ends up in a depression. We can see that depression here, this depression. That depression is called Hatch's pit. Pit. This depression is called a Hatch's pit. And what's the function? It secretes mucus to trap food particles. So, it secretes mucus to trap food particles. Next, atrium. So many times I already told you about this cavity. It is the cavity seen around the pharynx. It is formed from the ectodome. It is lined by ectodome. That's what. It is a large spacious cavity surrounding the pharynx, and it opens out by atriopore. That's all about the atrium. Then regarding the fins, paired fins is totally absent. That doesn't mean that it doesn't possess any fins. It possesses fins, but paired fins are absent. Then which are the types of fins present in cephalochordates? Three median unpaired fins are present. They are dorsal fin, caudal fin, and ventral fin. We know that I already shown you the dorsal fin, caudal fin, and ventral fin of that cephalocordate in the former video. Once more, I am showing. This is the dorsal fin. It is extending throughout. This is the caudal fin, and this one, the fin that present under the body of the organism. That is a ventral fin. This dorsal fin, it is a membranous fold extending the whole length of the trunk mid-dorsally. Okay. And the dorsal fin is supported by so many fin rays. So from its anterior end to the posterior end, that dorsal fin present, it is supported by so many fin rays. What's its number? About 250 to 300 fin rays are present. And the dorsal fin, it continues and turn around the tail. It continues and turn around the tail as caudal fin. Caudal fin. Caudal fin. and then it turns towards the ventral side of the body as the ventral fin. So dorsal fin itself is giving rise to caudal fin and ventral fin. As it continues, as it continues with the tail and the ventral part of the body, it forms the caudal fin and ventral fin. And the ventral fin also possesses so many fin rays, but caudal fin doesn't possess any type of fin rays. Then another structure that is epiplure. Epiplure. This is the ventral side of the Branchiostoma or Amphioxus. What about the appearance of the ventral side? It's just like a ruffled. It is highly folded. That means it is wrinkled, like ridged like appearance. That ventral ridged surface of its trunk is called the epiplure. It is the ventral longitudinally ridged surface of the amphioxus is called epiplure. And this epiplure forms the floor of the atrium. Form the floor of the atrium. We know that atrium is the cavity formed. It is lined by ectoderm and it covers the pharynx. And its floor is formed by the epiplure. And that lateral edge, we can see this is the lateral edge of this epiplure is produced into two thin hollow folds. What's the name? Its name is metapleural fold or atrial fold. So what is metapleural fold? The lateral edge of the epiplure is produced to two thin hollow folds called the metapleural folds or otherwise called atrial folds. And this metapleural fold, it is continuous with the oral hood. It is continuous with the oral hood and posteriorly it meet around the atrium. This is the atriopore. So posteriorly it is meeting with the atriopore or atrium. Then regarding the exoskeleton and endoskeleton, it doesn't possess any exoskeleton. Its body is covered with a soft skin. So there's no need to talk about the exoskeleton. Then endoskeleton. So many endoskeletal structures like notochord, some gelatinous rods, plates, fin rays, tough fibrous connective tissues, all those structures are present. Body cavity. What about the body cavity? Body cavity is true coelom and it is enterocoelic coelom. What is enterocoelic coelom? I already explained to you. Then this coelom, it is the space of the coelom is limited towards the anterior end because of the formation of atrium, another cavity lined by ectoderm. Then what about the nutrition? It is a microphagous animal. It feeds on microorganisms that are present in water. It is a ciliary feeder and it excretes with the help of excretory structure called a protonephridia. What is protonephridia? We have learned. We already know. Next, about the reproduction. Reproduction, I already told you in the former video. It is gonochoric, that means sexes are separate. There is, even though the sexes are separate, there is no difference between male and female, no sexual dimorphism. That's what, there is no discrimination. We can't distinguish between a male and a female. Then fertilization is external and development takes place through the formation of a larva. So larva stage is there. That's all about the detailed aspects of branchiostoma. Then it is important with regard to its evolution. So we need to learn about that aspects also. Evolutionary significance of branchiostoma. Why it is evolutionary significant? Because it possesses a mixture of primitive, degenerate, and specialized features. So it's a special organism. It is not considered in the normal line of the evolution course. Instead, it is considered as an outshoot from the normal course or the line of evolution. It is considered as an outshoot as it possesses a mixture of primitive, degenerate, and specialized features. So let's see which are the primitive features it possesses. It possesses certain primitive coded characters in an unmodified form. In an unmodified form, it possesses so many primitive coded characters. And also, it possesses some non-coordinated characters from its ancestors as a reminiscence of its ancestry property. So, let's see which are the primitive features. Persistence of the code and absence of distinct specialized herd. There is no specialized herd and absence of paired fins or limbs. Then enterocoelous coelom, we know that what is enterocoelous coelom, that is a primitive feature. Ciliary mode of feeding is a primitive feature, and absence of jaws, of course, it's another primitive feature. Presence of endostyle and protonephridia for the purpose of excretion. Then last one, paired and segmentally arranged gonads. That's another primitive feature it possesses. So, those are the primitive features of this Branchiostoma or Amphioxus. Then it possesses certain degenerate features. Degenerate features means what? That means once it is believed that it is an advanced organism like that of a fish, and owing to its adaptation for a solitary and also sedentary mode of living, it need to shed off some of the advanced features. It need to discard some advanced features. So, which are those features? For suiting with the sedentary mode of life, they lose some features that features are degenerative features. Which are those features? The absence of well-developed brain and specialized sense organ. That means formerly they possess these structures, and for suiting with the sedentary mode of life, they degenerate these structures, a developed brain and specialized sense organ. Then absence of any cartilaginous or bony endoskeletons. First they possess, but for opting to a sedentary mode of life, they need to shut off. They need to give up this cartilaginous or bony endoskeleton. So that also a degenerative feature. And that forward extension of notochord, that feature, it is hindering the proper development of brain. So these are the degenerative features. Then it possesses certain specialized features to adapt its special mode of life. Which are those specialized features? Prolongation of notochord. That prolongation of notochord is an adaptation that is helping it for burrowing, to dig burrows in the sand to remain during the daytime. And yeah, elaborate oral hood and velum. That is another specialized feature, and this structure is helping it to filter. Yeah, they stands as filtering structures. Then a spacious pharynx and endostyle and an extensive atrial cavity. Pharynx, endostyle, and atrial cavity. So these are all very spacious. So that's also a special feature to support its sedentary mode of life and all. And so these are all about the important things about the branchiostoma. So we can wind up today's class and section. Thank you.
I'm an icon, man. And my girl about a 10. I should fuck her in the Benz.